Hi everyone, welcome to this new lecture on Axi4. So let's get a quick recap of what we discussed in the last lecture. So the first thing that we discussed in the last lecture was about the connectivity. We looked into various configuration. We told like we can have a single master, single slave configuration, or we can have a multi-master, multi-slave configuration. And we concluded by saying that whenever the number of master or number of slave is greater than 1, either of the master or the number of slave components are greater than 1, we need an interconnect. The second thing that we discussed was about the driving and the sampling in an Axi4, and we said that the driving or the sampling of signals in an Axi interface will always happen at the passage of the clock. The third thing that we discussed was about the valid ready handshake. We told that these are the two common signals present in each of the channels. Okay, and whenever one component want to put a valid information into the bus, it has to assert its valid signal. So suppose this is the component C1, the other component is C2. So the component that has to get a valid information has to assert a ready signal, and at the certain passage of the clock, this communication will happen. Okay. The other thing that we discussed was about the reset, and we talked about an important concept called as asynchronous assertion and synchronous deassertion, in which we said that whenever the system want to come into the reset, means the system want to get into the reset, what it has to do is just put its reset down, and that will mean a reset. But the otherwise, whenever a system want to come out of the reset, it will happen only when the passage of the clock after the reset got deasserted, the system will come out of the reset at that point of time. So this is the point where we are out of reset. Okay, so this was the quick summary. Now let's move forward. So we talked about a single master and a single slave, and when we look into this configuration, we know that this communicates via an Axi4 rules. And the first question that comes to our mind is simply like, who is the master? Or how a person decided that this is going to be the master and this guy is going to be the slave. So the simple idea is like, whosoever is having the authority to initiate a transaction, that component will be the master. Having an authority means the master can always initiate a transaction. By a transaction, what it means is a write or a read. So a master will always have the right to initiate a write or a read transaction. Okay, the opposite is not possible. The slave does not have an authority to initiate a write or a read transaction. Okay, so if we want to look into it further, suppose there is a processor named as PR, and we have a memory. Generally what happens is processor does its work, okay, and what it does is it stores its data or the code, whatever it is, inside a memory by giving a write command or a store command. It reads whenever it wants some data from the memory, it gives a write command or a load command. This is the way it happens. So here the authority of writing or reading is with the processor only, right? This is the guy who is having the authority. So this is actually the master in our sense. So suppose I say opposite. This is the memory. This is the processor. Can a master give a memory give a write command asking the processor to, okay, I'm going to write into your registers? The simple answer is no, right? And you cannot ask for a read also. So this gives a better idea. Okay, that depends upon the implementation actually, who is going to be the master and who is going to be the slave, how your design looks like. Okay, and you have to decide that which is the component that is going to have the authority in your system. Okay, so hope this answers well. So now moving forward, the data transfer. This is the master, this is the slave. So data transfer actually happens into both sides. Okay, so for the read case, that will be from slave to master, and for the write case, it will be from master to slave. But the initiator will always be the master. Okay, so we can see this master having the authority in two of the cases. One is the write and one is the read. So let's start with the write case. So what a master does in the write is, it can be divided into three steps. First, it uses the write address channel. The second step, it uses the write data channel. And the third step, it uses the response channel. Okay. How it uses, we'll see. Okay. One point to know, this steps can be interchanged. That is, the data can come first and the write address can come later. Okay, we'll see that case also, but for a generic case, we are telling that for a write case, master is going to use a write address channel first. Okay, so how a master initiates the transaction is, it puts the address. I'm only discussing about the important signals here. These are means very important signals. So what a master does is, it puts the address in which it is going to make a write into the address bus. Also, it puts an identifier that will be utilized in the whole transaction for identifying this. Okay, so this transaction identifier will be used in response also, and if possible can be utilized in data transfer also. Okay, so the master gives this information into this bus, okay, to the slave using the AW channel. Now slave has the two informations. One is the address in which it has to make a write for the upcoming data from the master. Okay, also it knows that the address that is going to be written, the data or the response has to be sent back with a particular ID that will match this AW ID. Okay, if it doesn't make sense, we'll make it clear. Okay, so the slave actually got two major informations. One is the address in which the master is going to write, and thus that address actually corresponds to the slave memory. Okay, so this is the AW address in which the master is going to do a write. The second information that a slave got is this: whatever the transactions are related to this memory address are to be identified with this particular ID. That can be given a different name and different channel, but the ID will remain same. Okay, now we'll see how this identification number actually affects our transaction looks like. Okay, so let's move forward. So let's make a diagram first. So suppose this is a time frame. Okay, this is the time domain, and I'm taking all of the three channels This is your write address channel, this is your write data channel, and this is your response channel. Okay. So first thing that we told that what a master does while initiating a write transaction it is put the right, and this can be identified as AW0. Okay, this is the first thing that a master does is put its address and the AWID in the address bus, address and the control bus, right? So definitely this transaction happens with some valid ready handshake. So first what a master has to do is it has to assert its AW valid. At this point, when the AW ready comes from the slave, what happens? Now the signal is the master can reassert its signal, right? So now your address bus is empty. Okay. So if you look into the other domain, this was your clock. The first step that the master does is for a write is it puts its W valid high, AW valid high, the valid information here. That is AW address. You can keep it as address if the AW address is the signal. Okay. Along with that, it also gives the AW ID. Now we know that this information cannot change until unless the ready comes. So slave after some cycle gets ready for receiving the transaction. So it says I'm ready to receive the transaction. It gets this process and it's pull down its transaction. It's AW ready. It can also reasserts its information that it has given on the address channel. Okay. So this was the AW ID that is carrying an ID signal, and we have the coming in from the slave. Okay. This is the same thing that we have shown here. So the first transaction initiates with the AW valid getting high, and the transaction ends with a means the address transfer ends with a ready getting high. Okay. So this is the point where your transaction starts. Okay. Okay. Now, when the AW ready comes, the master has left the control of the bus. Okay. Or because the ready has come, it can initiate another transaction, changing that AW address. Okay. So because the bus was now empty, it can give another transaction. Okay. Similarly, we can give another transaction AW2, suppose say, and here the AW ready will keep on coming and this transaction can change. Okay. Now suppose say, okay, that's fine. So suppose after this, the master what it does is it puts the data on the write data channel, and it again happens with a valid ready handshake signaling, and the valid ready handshake signals here are W valid and W ready. But this data transfer doesn't end with only with W ready, it also needs a additional signal that's called as W last, that we'll see what it is. So suppose this transaction is G. So for each of these address transfers, the data transfers will be done for each of the address transfers. Suppose these transactions are D2, D1, D0. Now D2 corresponds to the AW2, D1 corresponds to the AW1. Along with in the AW0 or the AW1 or the AW2 address transfer, we also send the IDs. I'm considering that AWID corresponding to this is 0, for this it is 1, and this is 2. Okay. Now, a later period of time after which the address transaction happened, the data came to slave. Now, slave has to identify among these many transactions, AW0 transaction, AW1 transaction, or AW2 address transfer, this data belongs to which of these data transfers, which of the address transfers. Okay. So how it can identify is the master can send a WID also corresponding to each of these transactions. That will be exactly a match of this AWID. Okay. So for this it will be WID equal to 1 and WID equal to 0. Now the master sends the address in case it was doing an address transfers. Okay. Now that information is already with the slave. Now slave can easily identify that this particular transaction D2 has a WID 2. That means it will be corresponding to the address transfer 2. Okay. It has to determine, right? The slave has to determine which memory address I'm going to write this data into. So it is identifying with the help of WID, AWID matching. Okay. Now, the other case, suppose the master is not supplying the WID to this data transfers. In that case, do we have a solution? Yes, we have. The one solution that we have is we have to keep the ordering of the data similar to the address. The order in which the address transfers were being made, we have to ensure that the data transfers are also being made in the same order. Okay. So now what can happen is the slave knows the rule that the data that comes first or will also have the address being written first into the address bus, right? So it knows this address corresponds to this, AW1 corresponds to D1 and the AW3 corresponds to D2. Okay. So in AXI4, actually we don't have a WID. This is the case for the AXI3. We don't have a WID, so we need to have the data ordering in the same way as of that of the address ordering. Okay. So there's an important point that we should remember, that we don't have a WID in case of AXI4. Okay. Now moving forward, how actually this worked out is again with the help of handshaking signals. Again, we said like there was a W valid signal and there was a W data signal that was being given by the master. At some point of time, slave asserted its W rating. This clock pulse, this transaction happened. Okay. This is the same thing that happened above. So this data transfer has been done with the help of this valid ready handshaking. Okay. The slave will send the response back to the master. So this is the third step. So what the response will tell is when the master was actually trying to write the data, whether it was a successful write or there was an error. So for a successful write, the slave gives a response okay, and for an unsuccessful, it generally gives an error. So it could be a slave error or a decode error. and there could be an okay or an exclusive okay that we'll discuss later about the responses. And this response will go back to the master. The slave goes into which channel? Sorry, the response goes in the response channel. Okay. So this response will come after a certain period of time. And say again the response came out of order, that is not following the order of the write data or the write address transaction. And it came like B0, B2, B0 and B1. B2 corresponds to the third response, B0 corresponds to the second response, and B1 corresponds to the second response, sorry, B0 corresponds to the first one. Okay. Now again, there is a BID corresponding to each of the transaction, okay, which the slave sends back to the master by giving the response. So suppose it is giving the response for the AW0 transaction, then it is going to send the VID equal to 0. Okay. When it is giving the response for the AW1 transaction, it will going to send the ID as AW. Okay. Along with that, the responses will go correct. So in this case only also, we can have this ordering differences, means this order is not matching the address order because we have the BID. Otherwise, we have to match it. Okay. Otherwise, the response order also has to match to the address order, right? So this is actually possible in AXI4. In AXI4, the identification number for the response is also there. So slave will be able to send the responses in any order. And such a transaction where the responses are not in order is known as out of order transaction. Second thing is when we will say that a particular transaction is complete. A transaction basically means a write or a read. So the first transaction that was initiated was at this point when the AW valid actually got asserted. This is the starting point. When the transaction ends is the point where the response for the transaction comes. So the response for the transaction is it is B0, right? So this is when the transaction actually ends. Okay. From this point to the point where the transaction ends, the transaction is actually outstanding or pending. Okay. Now the XI4 allows the master to put multiple transactions which are not before completion of the previous transaction. And so we can have multiple transactions in the buses which are actually pending or outstanding. And that's why we say that AXI4 supports multiple outstanding transactions.